About last lesson, we were looking into Venn diagrams. Okay, so I'll just do a quick recap on what we did. And we identified what are some elements of the Venn diagram. So remember that on a Venn diagram, this area here represents your intersection, or it looks like this, that symbol. Okay, so that symbol, for example, A intersection B refers to this middle bit there. Okay, you also remember that these two circles, okay, represent your union, and the union is this symbol. So when I refer to A union B, it refers to all of these two circles. Okay, A, okay, is referring to everything that's in A. Okay, B is referring to everything that's in B. Okay, so keep that in mind. A union B, if I have like a dash like that, what that's saying is I only want everything that is not B. Okay, everything not B. So that would be everything that's A, and then everything outside of it. Okay, excuse their horrible drawings. And then the opposite of that obviously is A dash union B, which is saying everything that's not A. So that means it's everything here, and it's not A. Okay. All right, let's keep going. So some symbols that you need to keep in mind. Oh yeah, one more thing as well. That number on the top right refers to the universal. So the universal set. So that refers to the total. If I was to add all these, now I know that these are like numbers, but this is talking about individual numbers. So how many numbers do we have altogether? It says there's 6 numbers right up there. Okay, but technically, when you use a Venn diagram, it's not about counting the numbers individually. You're actually going to be adding them together. But just keep that in mind for future reference. Okay, and the numbers on the outside are the ones that are neither A or B. Okay. And also remember mutually exclusive events. So just to recap, mutually exclusive. Okay. Oops. Just means no intersection. Okay, no intersection cannot happen at the same time, or cannot occur at the same time. And also no common, there's no, nothing is the same between them. Okay, so that means no similarities. Similarities. Okay, so just keep that in mind for mutually exclusive. All right, so let's get into two-way tables. So a two-way table is basically just another way of representing a Venn diagram. Okay, it's just another way of representing a Venn diagram. Okay, and it's basically, instead of seeing it in this way, so this is your typical Venn diagrams. Okay, there's your Venn diagram. Instead of seeing it that way, you'll see a two-way table that looks like this. Ooh, one thing I also forgot to mention, A only, B only. So remember I said A union B means everything that's not B. Okay, if you have A intersection B dash, that means A only. Okay, so see the difference when you change the symbol, it actually changes the meaning of it. Union B with a dash means everything that is going to be not B. So I want this and everything outside it, yeah? But if it's intersection, that's just saying I only want everything that's A. So I'm focusing only on this. And that's it. Everything else I don't need. So I only want this one. Cool. And similar with B only. Okay, so both of these actually share the same information. Okay, they both share the same exact information. Just a couple things of how this works with a two-way table. Have you guys used two-way tables before? Okay, really easy. Okay, it's basic addition. So for example, this column here this number here refers to the total for this row. So 1 plus 4 equals 5. Okay, same with here, 3 plus 2 equals 5. And you'll see here 5 plus 5 equals 10. Okay, and it works downwards as well. 1 plus 3 is 4. 4 plus 2 is 6. And then 4 plus 6 equals 10. Okay, so it's pretty straightforward. It's really easy to fill out once you get the hang of it. And notice how each of the elements of the Venn diagram is found here. So you can see A intersection B is found here, and you can see it's because where A and B meet together. Okay, so that's the intersection. Okay, A B dash means it's A only. Okay, so just A by itself, just A only. And then what else is it? Not A, not B. So everything outside of the Venn diagram, not A, not B. Okay, that would be 2. And what else is there here? This is the universal set, as you can see with this symbol there. Okay, so that's everything added together. So let's actually fill some of these out and see how we can make it work. So for example here, you've got the numbers for maths, English, and what they all like. Can anyone tell me what would the universal set for this be? Now it's not 3 numbers, now we're just going to add the numbers. Yeah, so what's the universal set here? 19. Good. 19. So 7 plus 6 plus 6 is 19. So all up, this should equal 19. Which means that when you do a two-way table, I always start with the bottom right number here. Put 19 in there. Okay? And then from there, you can go with the rest. What does this symbolize? The middle number. Starts with I, it's this one. Oh, sorry. This symbol. Intersection. So the intersection, the next one, I put that number here. The 6, because it's English and math. So they both go there. Intersection. Okay. Maths only is 7. So if I wanted to go maths only, that would mean it's math but no English. Right? So math but not English, because it's math only. So it would be 7 right there. And then for English only, there, 6, that would mean English, but no maths. So that would be here, the 6. And the numbers, when you add them up, should equal what they equal here. So you'll be adding them all up to get them. So let's actually fill some out here. Actually, I'm going to make a new one, my own one here. I'd like you guys to copy this down. Let's see if you guys can make a two-way table for this. So I'm just going to make a Venn diagram. Don't copy the Venn, but copy the two-way table. I'll just call this A. This can be B. We'll call this 7, 2, 3. And you've got 4 here. And then for your two-way table, this is what I want you to... Actually, just copy it all down. You'll need it. So this is your two-way table. Okay, this is how I do it. So you'll have, might need a bit more space, but this is your A, there's your B, there's your A, there's your B. You can put them in a box if you want to. Like that. Okay, so there's your A's, there's your B's. Okay, so what you want to do is just make sure I put the right ones in there. A, B. Sorry, guys. Oh, I put the wrong ones. My bad. Should be A, B, B. My bad. That's correct. So it should be A, and then B, B. Yeah. And then you've got one. One of them has always got to have the dash. So A, not A, B, not B. And you also need to include some more totals here. So we'll add some more boxes here. Okay. And then we're going to try and fill out this table using the information here. So what I can see so far in the Venn diagram is my universal set is going to be 16. Okay, so my universal set altogether is 16. That means on the bottom right, you always want to make sure that you put your universal set. You don't have to put it first, but I like to put it first. So I know that when I add things together, it should equal 16. Okay, next I always like to put the intersection because I know that it's there. So the intersection of 7, A and B is 7. Okay, another thing I like to put there as well is maybe the neither A nor B, so the number on the outside. So neither A nor B would be down here, this box. So neither A nor B. So that would be 4. And with most of these, you'll find that you actually only need 4 numbers to fill it out. Yeah, you only need 4. So we'll use one more number. Let's go with A only. Okay, A only. So that's saying A but not B. So that would be this one. A but not B. So that means that's 2. And then from there, you can actually fill out the rest of it really easily. So if you go with the addition rule that we've been doing, 7 plus 2, that equals 9. Okay, 9 plus something equals 16. What could that something be? Anybody know? 9 plus something? 7, good. Something plus 4 equals 7. What's this something? 3. Then we can finish the rest off. 7 plus 3 is 10. 2 plus 4 is 6. And if I add them up, 10 plus 6, 16. 9 plus 7, 16. There it is. Really easy. And you can actually match it to the Venn diagram here as well. So for example, if I wanted to look at B only, which is 3, and I can see that B only is B but not A, so it's 3. And as a total, if I looked at all the B's in total, so all of the B, what does that equal? All the B's? 10. And I can see that all the B's equals 10. Okay, so pretty straightforward, good to use. Use it when you need it, but generally that's how you fill out a 2A table. Okay, so it's just basically addition. That's all it is. Okay, so the last one here. So final activity. So on our activity sheet, so on this sheet here, this is the final activity that we're going to look at. Okay, and then we'll start working. So it's the second sheet, this one here. Second page on that one. I should have just printed all this together, guys. My apologies. Yep, the one with the 3 Venn diagrams. Yep, that one. So as a final one, just to finish up, then we'll start working using a Venn diagram and find the probabilities of this. So when we're doing the probabilities, it's the PR, yeah? It's going to be as a fraction. All right, so looking at this, I can see, okay, that we need to figure out first what is the universal set. Okay, so it's going to be 4 plus 11. Okay, can't do it off the top of my head, but let me just add them all up. 4 plus 11 plus 18 plus 10, 5, 7.
For sure it's 80.
Yeah, is it? Okay, let's double check. Yes, you can see a photo of me there. Cool, 80. So let's treat the universal set as 80. They haven't left much space for us there, but universal set is 80. So that means everything has to be out of 80. All of our answers. So how much of the countries how much did not visit any of the countries? So that means anything outside of the 3 circles is 16 out of 80. Can that be simplified? Yes. Anyone know what to? Can make it 2 out of 10 and then simplified further to 1/5. Good. Visited all 3 countries would be 5, because it's all 3 would be that intersection there. I see that. So all 3 countries would be 5 out of 80. Okay, simplified to 1 over, I think it's 4, no, 15, it's what, yes, 16. Wait, yep, 1 over 16. Visited China, okay, China I'm assuming is C. Now, that's a trick question. Is it China only or anyone that's visited China at all?
Anyone.
Good, anyone that's visited China. So that means you're adding all of these guys. So that'll be 15, 5, 30, good. 30 over 80, simplified to 3 over 8. Only visited China, so only China would be that 4. 4 out of 80, simplified to 1 over 20. Visited at least 2 of the countries, so at least 2 countries. That's a trick question as well, because that would be anything or anybody who's visited 2 countries. What are we up to? All right, so this is a trick question because it's saying at least 2 of the countries. Am I missing one more? Yes, which one am I missing? The middle, because this person's visited 3, or these people have visited 3. So I'm adding 10, 7, 5, 11, and that would be, what's that, 15, 22, 33. Thank you. 33 out of 80. That cannot be simplified. And probability of someone visiting only 1 country, okay, well, there you're looking at the ones that are only single countries, or C only, V only, T only. So that would be 22 plus 9 is 31. 31 out of 80 countries. And the last one, visited China, Vietnam, and Thailand, but not China. So that means Vietnam and Thailand, but not China. So that means we're not looking at this. We're not looking at this. Neither are we looking at this or this. Okay, now, what this is saying, this one's a little bit of a tricky one because it might be hard to decipher, but it's saying Vietnam and Thailand. So which one am I looking at? Just the intersection. Good. Vietnam and Thailand, but not China. So that would be 7 out of 80. Easy. Okay, so you got to read some of these a little bit properly. Some people might interpret that as visited Vietnam. So they would include this, and then they'd say visited China, Thailand. They'd include that, but it's not. If it said Vietnam or Thailand or both, but not China, then maybe, but not in this case. Okay. All right, last one here. What's this one here? 32 liked. Okay, this one's easy. So let's just do this last one here. Generally, this is going to be a Venn diagram question, so you want to start off with your Venn diagrams, and I haven't really gone through this with you guys, but always draw your rectangles with your 2 Venn diagrams. Yeah? So you got your 2 circles, and more likely than not, they're going to have an intersection. So let's start with that. There's your Venn diagram. Does anyone know what's the universal set already? By reading the question. 50. So this should all add up to 50. Okay. And there's 2 sports here, snorkeling or cycling. Let's just go S or C. Okay, the results showed that 32 liked cycling, 15 liked snorkeling, and 12 liked both. Okay, now tricky because you can't just straight away put the numbers in like this. You can't go 32, oh sorry, wrong way, 32, 15, and 12. Why is this incorrect, guys? Anyone know? Why is this wrong? Yep.
Because maybe they include people who like first.
Yeah, exactly. So in these statements here, this one and this one, they included people who like both. And also, can anyone think of a reason why this is already wrong? Anyone know? When you add them up, what should it equal to? It should equal to 50, but does it though? It doesn't. So it has to add up to 50. So it's already wrong. So we can't do this. Can't write it like that. So how do we start this? Well, one thing you can do, or one thing I like to do, is I always start to write down the intersection. So that means both, which is this. So how much like both? 12. So start with that. That's definitely going to be correct. 12 is both. Okay, then how do I figure out what goes in snorkeling and in cycling? Well, if you can see that 32, for example, liked cycling, so that means this whole thing should equal 32, right? So when you add these 2 together, it should equal 32. Therefore, if you've already got 12 in here, what should we put in here? 20. Because when you add them together, it has to equal 32. Okay, what's the next one? It says 15 liked snorkeling. So that means if 12 people already like snorkeling, how much people like snorkeling only? 3, because it has to equal to 15. Okay, so there's your Venn diagram so far. Now, we're not quite done yet. Okay, because what should this add equal to? 50. So if we add them all up, 20 plus 12 plus 3 equals 35. It only equals 35. So where's the rest of it going to be? None of them liked it. So the rest of it would be 15 on the outside because 15 of them didn't like it. So when you do this, make sure that it always adds up to that universal set. Always. And that's how you work it out. So start in the middle, then I'll start in the intersection, go with the onlys, and then figure out how much don't like either. And that's it. There's my Venn diagram. Easy. Okay, sorry, I'll pull that up again.